All right, so time for the culmination, right? Everybody go like this. We're going to bring it all together here. We're going to be using different rules at the same time. So we're going to have like a multiplication rule that we use in junction with a chain rule simultaneously, or maybe a quotient rule with a chain rule, right? You guys have seen this with a mix of quotient and power. You've seen it with a mix of power and product, but you've never seen the chain rule thrown in to all this stuff. So let's do it real quick. So if you notice, we have this crazy hairy function going on here, and you're like, I don't even know where to start. Well, where I would start is I would split it up, and I would realize that h of t is just two functions multiplied together. So let's call a of t that 3 to the t squared plus 2t. And then let's call b of t secant of t to the fourth, right? And now what we can do is we can kind of divide and conquer. We can find the derivative of this using the chain rule. And then we could do the derivative of this using the chain rule. And then we could use our power rule to bring it all together, right? So I'm going to show you kind of a nice way to keep everything organized. And eventually, maybe you won't have to do this, but when you're learning it for the first time, you might want to organize it this way. So notice I'm just working with a of t right here. So I'm noticing that a of t is a composite function, right? The outer function is going to be 3 to the t, and the inner function, g of t, is going to be t squared plus 2t. So if I find the derivative of the outer function, I'm just left with 3 to the t ln of 3. That's just our normal power rule. And then same thing here, that g prime of t is going to be that right there. So now think back to our chain rule. F prime of g of t is going to be the derivative of the inside right here times the derivative of the outside right here, which is how I got this. Derivative of the inside, which is that 2t, times the derivative of the outside. Notice instead of having t, and that's what they're getting at here, instead of just having that t, we have t squared plus 2t. That's the original function. Derivative of the inside times the derivative of the outside, making sure that the nested function is the original function. So that's a prime. I know what you're thinking. We haven't done b prime yet. Well, here we go. Let's do b prime. I'll move this over here. So b of t equals r times s of t, right? So again, I have two kind of arbitrary letters that I just kind of made up. You can use any variable you want to. I just used r and s because it felt good. And then I have to understand, okay, that the outer function is going to be t to the fourth, and the inner function is going to be that secant of t. So if I want to find the derivative of the outer function, just 4t to the third. And the derivative of the inner function, that's, you know, from our power rule that we were using before, or our trig rules that we were using before. So then r prime of s of t is equal to this thing right here. Notice we're plugging s of t into t. Finally, we can find that b prime, which is what we're looking for, right? And that's going to be s prime times r prime of the inner function. So the derivative of the inner function, that's where that secant times tangent is coming from, times the derivative of the outer function, which is this guy right here. Just dropped right down. Now, remember, a of t equals that, b of t equals that. We can rewrite, this is crazy, we can rewrite, let me move my picture. We can rewrite h prime of t as the first function times the derivative of the second plus the second function times the derivative of the first. And then what we can do is we can use what we just found, a prime and b prime, and we can plug them in to what we need, right? So a prime is going to be plugged in for 3t squared plus, so that's just going to get plugged in right here. And b prime, that's just going to get plugged in right here. So it's nice getting the work done kind of ahead of time so that you can just plug them in. You don't have to think very much. If you try to do this all in one step, it's going to be a lot of thinking, right? You're going to have to be, okay, you have to do the chain rule here. If you do it like this, there's not a lot, everything's so nicely organized for you. It's really going to help you a lot. So then what we can do is we can substitute in A prime and B prime. Oh, and it's not an attractive answer. You wouldn't want to go on a date with this answer for sure. But it is the answer. It is the answer, right? So bottom line, when you're doing this, it makes a lot of sense to organize it and break it up into smaller functions, and then to keep track of that kind of on the side so that when you go to plug it in, it's already done for you.